All right, so 3.4 notes. This set of notes, we're going to be talking about linear programming. And our goal is going to be to use linear programming to find maximum and minimum values. And so what this is we are going to be graphing a set of, or a system of inequalities. Okay? Now this system has, would have 4 inequalities that make it up. And you can see that it would have to be greater than this line, less than this line, less than this line, and less than, I need a 4th color. Less than this line. And what would happen when we use our post-it notes now, we'd have a post-it here. We'd have a post-it here. One up here. And one here. And so what we can see is this is what we would call a bounded region because it's just that region that is the solution. Okay? Whereas before, we've dealt with ones that were unbounded, like this, that keep going. If you were shading, they would keep going in this direction and keep going in this direction and keep going off in this direction. So that's unbounded. It keeps going, it extends. If you decide to zoom out on your graph, that that shaded region also continues. Does that make sense? So if you can see all the edges of your shaded region, and there's an edge on all sides, that's what we call a bounded region. It's unbounded if it goes on forever. See the difference? And so what we're going to be dealing with is we're going to have more than just 2 inequalities that we're going to have to graph for linear programming. And so this one we have technically 4. This is actually 2 of them. This is y is greater than or equal to 3 and y is less than or equal to 6. So there's 2 there. What do those look like when we graph a y equals equation? Horizontal line. So we have a horizontal line that's going through 3, and we have a horizontal line that goes through 6. Both of them are going to be solid lines because they're or equal to. So I have a solid line at 3, horizontal through the y-axis at 3, and I have one at 6. Because that says y is between 3 and 6. So I know that if it's between 3 and 6, it's going up on the 3 and down on the 6. So I'm also going to draw these arrows in too, going towards each other, because I know y is between 3 and 6. Is that okay so far? This next one says y is less than or equal to 3x plus 3. So my y-intercept is at 0, 3. And the slope is 3. So I'm going to go up 1, 2, 3, right 1. Can't even fit another point up there, but that's okay. We can fit one down here, and then we'll connect it with a straight edge. And again, that's a solid line because it's less, it was less than or equal to. Where is y less? Is y less up or down? Down. So from these points, I'm going to draw arrows down. I have one more to still graph. Y is less than or equal to negative x plus 8, so 0, 8. And negative x, negative 1 is my slope, so down 1, right 1. I'm going to make sure I put enough points on until I run out of room. I'm going to fill up my entire graph that's provided. This one also connects with a solid line because these are all or equal to. This one says y is also less. So I'm going to take, and y is less going down, so I'm going to draw down arrows on all of those. So, then I use my Post-it notes. I'm not on this side of the orange, so I'm going to cover it up. I'm not on this side of the blue, so I'm going to cover it up. I'm not on this side of the green, so I'm going to cover it up. And then I can put one more on there. If you need more Post-its, just let me know. That side on the blue. So then I have my region. Is this bounded or unbounded? This one's bounded. There's boundaries on all sides. The next thing it says to do is to name the vertices. What are vertices? What's a vertex? It's the point of the V because that's where the two halves connect, right? Where the two lines meet. So a vertex is just where two lines meet. So these two lines meet right here. So we have a vertex right here. So we have to identify what that point is. 5, 3. These two lines meet here. They're all the corners of your region that is your solution. What's this point here? 0, 3. Here's a corner and there's a corner. What's this point here? 1, 6. What's this point here? 2, 6. So now that you have all your vertices labeled, what we want to do is we have to find the maximum. Now the maximum is going to happen at one of the vertices. Okay? Now it depends on what you're given if you want a maximum or a minimum. A company would use this to figure out all possibilities for creating something or for, whatever it is they're working on. And then what they're going to do is P is going to stand for profit. You want to maximize your profit, right? A business wants to make as much money as possible. So they want to maximize their profit. And so in order to maximize the profit, it's going to happen at one of the vertices. So we're going to take and we're going to find the profit if we plug it in for 5, 3. So 5, 3, the profit would be 4 times our x value is 5, minus 2 times our y value is 3. Our profit would be 20 minus 6 is 14. Let's find the profit at 0, 3. The profit would be 4 times 0 minus 2 times 3. The profit would be 0 minus 6 is negative 6. Well, definitely don't want a profit of negative 6. So right away, you know that's not going to be the maximum. So far, 5.3 is the maximum. The next one would be 1/6. The profit equals 4 times 1 minus 2 times 6. Profit will be 4 minus 12. 4 minus 12 is going to be negative 8. Well, that's not a good one. Last one that we haven't done is 2/6. The profit equals 4 times 2 minus 2 times 6. 8 minus 12 is negative 4. So my maximum then has to be at 5.3. Where my profit is 14. So you look at your profits. You have a profit of 14, negative 6, negative 8, or negative 4. 14 is the largest. You do have to show me that you plug it into all of them, though. Okay. Then it says to find the minimum. So if they're talking about your cost, that's how much money a business spends on something. So your cost is how much money it takes to make a product, and then your revenue is how much you're going to sell it for, and your profit is the difference. How much money did you make? Okay, so we want to minimize the cost. You want to maximize the profit, because the smaller it takes to make it, and the more money you can sell it for, that margin is going to be larger, and you're going to make more money. Okay, so our cost, we have to do the same thing. We're going to plug in each of the vertices. We're going to plug in 5.3. Now notice that equation is different, so we have no idea which one it will work. So 3 times 5 plus 2 times our y value is 3. So the cost for that one's 21. Plugging in 0, 3. Cost would be 6. Plug in 1, 6. Cost is 15. Last but not least, plug in 2, 6. Definitely not that one. So the lowest cost is at 0, 3, which had a cost of 6. So then we would circle that one. This is your lowest cost. Okay. That's all the notes for that section. So if you're looking at the assignment here, for number 1, the first thing it says is find the values of x and y that maximize or minimize the objective function for each function. This one's giving you a profit function, so it wants you to find the maximum. It gave you the vertices already. It showed you what the region looked like, and it gave you that there's a vertex at A, 0, 0, B, 5, 0, C at 4, 2, D at 0, 6. So you're going to do exactly what we did in those last 2 parts and figure out which vertex creates a maximum profit. On this one, notice this is unbounded. It's hard to see what's shaded, but this is your shaded section. It goes forever. It's unbounded. Okay? It gave you the vertices then. We're here at R, Q, and P. So you're going to figure out which one will be the minimum. There. Okay? That's all you have to do for those, is figure out which one creates the minimum. Show your work of plugging in those vertices. And then for 3, 4, and 5, you're going to do it just like we did for example 1, where you're going to have to start with graphing. You're going to have to name the vertices. And then what you're going to do is you're going to figure out what makes the minimum profit or the minimum cost. So here's your minimum equation. You'll show your work over here for that, and you'll identify your minimum here. Okay? Now for the minimum, when you identify it, I want you to give me the vertex that created it and the actual cost that it was. Does that make sense? Like you'll have all your work here, but then I want you to identify it here. Okie doke? So the rest of the time is yours to work. You guys have plenty of time and should be able to finish one or both of your assignments from today.